Thank you. So, I didn't want to have it in a classroom. I wanted a lab. Otherwise, you could have had in the auditorium itself, like we had in the morning. The reason for two reasons, After a good lunch, how we will all feel. Especially if somebody puts a PowerPoint, dimming all the lights, it will be, maybe you wish it could be that way, but unfortunately, it is a very active, interactive session. So I wish I will try to keep you all awake to the extent possible. And physics is always, physics is always very engaging. So I'm sure you will see more than what I talk. I always talk less. I will be able to show, and then I will make some of you to come as volunteers to show whatever it is. Okay, that is the whole idea. And I don't have to tell you, like many learning, most of the learning that happens in life happens by ourselves doing things. Okay, if you want to learn swimming, what do? You have to get into water. You cannot read books and say I am a swimmer. If you want to learn cycling, what they will do? They will put you on a cycle, push from behind. You go and hit something, fall down. Then you start learning. So learning by actually performing things is the best way, because many of the senses are involved in the process. And therefore, you remember whatever you do. And then you will try to ask questions. We always tell our students, ask questions, ask questions. What they will ask? You just show one simple thing. Immediately there will be 100 questions they will ask. You have to provide a context for them to ask questions. So these experiments are meant to be like that. So as somebody said, for 40-50 years, I have been going to many schools and colleges and showing these to motivate them to at least have one such experiment in every class they take under physics. It's difficult for teachers. Where to go, run around, collect resources. I saw it over the 40 years. Then I said, let me prepare all the things required with preferably very low cost material, so that it should not become very sophisticated and expensive. Then it defeats the very purpose. So we have made most of them with very simple, and then it has to be interactive. That means what? The students should be able to assemble them and they perform the experiment. So while you learn, you commit errors, mistakes, and mistakes are most important for me and for everybody. Without committing errors, nobody learns anything. Okay? But we always tell our students, don't do mistakes, don't do errors. I tell all my students, please, when he enters my electronics lab, first thing I tell him, blessings, your circuit should not work today, come on, go. If it works, he has not learned anything. Suddenly it somehow worked. Tomorrow the same experiment comes, it doesn't work, he doesn't know where to start. And therefore, the learning by actually performing, which we call experiential learning, several terms are there in this thing, But the importance is, it makes us fail. And failures are most important. Because at the time of failure, we start wondering. When you fall from cycle, you wonder, why did you fall? So what did I do wrong? So even when in my class, when I return the papers after correction, what I will say? Your work starts now. Don't look at the mark. Go and take the paper, see the answers that you have written, and see where you have gone wrong, why I have reduced marks. That consciousness, where I have committed mistakes, is more important. So next time you will certainly will not make that mistakes. Nobody wants to make mistakes. So if you recognize what is a mistake, I have not put a minus sign, I missed a factor 2, something like that. So then once you recognize in the exam, with the same question comes the student when he writes, at that stage you will suddenly remember, oh, this is what that miss reduced 2 marks for me, put minus, because our job is only to do that. Now keep on waiting, where he has gone wrong. Oh, no units, minus 2. Oh, no minus sign, come on, minus, like that. That is our job. That's what we have to do. So therefore, they should gain confidence in doing things without fear of failure. This is the most important learning in life. Okay? Nobody comes out without, if you buckle under failure. You have to come out of failure. and then see where you have gone wrong and do everything to make sure that next time you will not fail. So that is why when people say failures are stepping stone to success, and practice makes a person perfect, because while practicing you commit all kinds of errors. Then when you actual reckoning comes, you are able to recognize what are all the errors that I commit, how I should guard myself against such things. Therefore, this is the philosophy with which we will all work together now. And the other thing is, as I already mentioned to you, the whole exercise now that I am doing after retirement is to strengthen the hands of teachers by providing the resources to them, whoever is interested. It's not a marketing here. I'm only saying the philosophy. So I wanted to prepare things for each concept, how to explain in a very enthusiastic, fun way. Because only when you are in the ground state, you will be ready to get excited. So you have to be free. So I have established innovation labs during my course in Balavidya Mandir in Adayan, where the first concept I told the principal is, here you give me one class for 6, 7, 8, 9 in a week. They will come to my lab. You give me a place. Then I decorated walls, everything with painting and all that. Ambience is important. And then I put all the gadgets that I have. Each children will come, 2 people together. It should be like a lab, not desk and teacher. They both will, I will give an instruction. They will read and they will do. Each one will discuss. Peer learning is most important. What the teacher cannot convey, his friend will convey much better, effectively among themselves. They are in the same frequency. So they will learn and they will do the activity, and at the end of the activity, they will write a small 4 or 5 line, what they enjoyed, what they learned. Phenomenal. I put them on the notice board. Not me, I never enter because I am not expert in that. The teachers are the expert. But I trained one teacher and put her there. Our job is full time to take care of this lab, and then it was a phenomenon. The students were waiting. Next class is my innovation lab. He wants to run on the corridor, get into the class. And one fellow said, "Sir, why don't you make the whole day like this? Because there is no pressure, no exam, nothing." I told, no comparison. And all the teachers who come to the lab should only say, "Amazing, awesome, how did you do that?" That is all. Only positive comments. Nothing, what, you can't learn. See, that fellow has done, you are not even starting. No such comments. You have to only encourage them. Because everyone is like a time bomb. They have so much potential in them. And our job is to wake them up. Identify those talents that reside in them. It need not be in physics. It could be anywhere. It doesn't matter. But the teacher's job is only that. The institutions like schools and colleges are providing an atmosphere. So finally you find one fellow comes on stage, is like an oration. Suddenly he finds that he's a great guy in expressing himself. Or somebody in organizational skill. Those are also important. Finally, like Chetan Bhagat, he will do IIT and go to book writing. It can happen. You follow what I'm saying? So therefore, the important thing is to make them feel happy while they learn. If you make them happy while they learn, the learning becomes very effective. They will never forget. So I don't want to keep talking. That's not the idea. Therefore, I'm going to show you few examples. I have more than 50 items, small items, each one of them. I have handpicked some based on my own interest. But you are all welcome to come and have a look later at the end of the things to see what the others are, what I am not, because it's a time constraint. But that you are all teachers and would-be teachers. Therefore, there is no need for me to keep showing everything. It is only the philosophy which I am sharing. So I'll show a few of them as an example, and that is good enough for you, and you are welcome to come and even here what I am proposing to do is, I will take 1 or 2 volunteers to come here and do on my behalf. I will help them to do. And then we will try to see whether we can find the reason for this and all that. Okay? Any volunteers now? Yes, sir. Some of you here might have seen some of my earlier demos. Okay? I seek your indulgence. If you see something already you have seen, please, you mute it. Okay, so that others can answer. Okay, and it's always fun. So that second time watching is not a bad thing, You will reinforce. Okay, right. So, or volunteer, one come here, come here. Anybody can come. So this is everybody knows. This is a ping pong ball. Boy, mic stand. Thank you. This is a ping. Which they also should see like that. So it's a ping pong ball, right? And what will be the mass of this? Can anyone tell me what is the mass of this? You tell me, sir. Sit down. What is the mass of this? By chance, guess. 10 grams. Very good. Anybody? Any other? 3 grams. Very good. So you find you have to reasonably guess. That is called guesstimate. So if somebody asks what is the weight, you should not say 1 kilogram. You should not say microgram. Right? You should say reasonably 1 or 2 grams. It is actually 2.4 international standard, 2.4 grams. So it is very light. So if I blow, what will happen? Fly off, come, we will blow. But for enabling it to blow, I have got a plastic tube and a funnel. I am putting it inside the funnel and I am going to ask him to blow. Wait, don't blow. I am going to ask him to blow fully. Okay, now let us guess what will happen. No. I should ask in the standard way, which we have been all trained from a LKG. What is that? A, the ball will not come. B, the ball will come to some height and stay. C, the ball will not at all move. D, none of the above. Bubble, tick, whatever you do, and then you will get 80%, right? That's how we are all doing. Can anyone say A, B, C? D is there? No. Come on. I have not told you. Whenever I ask question, I expect only wrong answer. Please, don't give me any right answer. Why? The spirit of science is that. Okay, everybody said sun rises in the east and then settles on the. One fellow came, what nonsense! Sun is not moving. Earth is moving. What guts that fellow should have had to say what we are all seeing. What happened finally? He was condemned as a lunatic. You know that. So that is, therefore, in science, we should never be afraid of giving an answer. What you say, it may be wrong to many people. Tomorrow it may be proved right, for all I know. Right? Newton said something. Then somebody came, Albert Einstein. What he said? He didn't say Newton is wrong. He brought new ideas. And then that made Newton's ideas are good only at certain limitations. And beyond that, if you want, you have to go to Einstein. So that is how science progresses. So I welcome you all to give any answer that you think. I allow the most wrong answer. Is that okay? Now tell me, what will happen? A, B, C. B. Good. Anybody? C? A? C. Good. Let us see. Now you have to blow, yeah. Okay? You had a good lunch? Good. Then I am confident it will work. Let us see what. Please, I hope the fan is off. No problem. Nothing will happen to the fan. Come on, blow. Come on, try, man. Try it. I think this is Daisarama. Okay, no problem. Okay, he's blowing. Nothing is happening. Can you see that? Anybody wants to try? I have a better lung power. You want to prove? You can. Now, therefore, so we come prepared for such exigencies. So what I have done is, I have brought a blower. You know what a blower will do? Good, works. Blower works. Good thing. So this is a blower. You know what a blower will do? What a blower will do? What a blower will do? Anybody? Don't say it will suck air inside. Blower will blow air out. Right? Come, sir. So you can hold this. I'll put it here. Now I am going to use machine power. Right? இது வந்து ரொம்ப அழுத்தாதீங்க, காற்று வரணும். அதை ஒரு நிமிஷம் பாருங்க. இதை அழுத்தி you can lock. You know that. There is a pin. அதை லாக் பண்ணிட்டு. So he is going to blow now. See, let us see whether it will hit this roof. Come on, try. Nothing is happening. I am going to drop it. So this is what we call Murphy's law. Okay. So now இப்படி reverse பண்ணிடும். வாங்க சார் ஆன் பண்ணுங்க. இது போட்டு reverse பண்ணுங்க. So I just now reverse. Usually even when I invert it, the ball will not come. If you have very high speed air coming out. And unfortunately I can only say that. Now I'll do something else. Now I put a tube reverse. So it's a small nozzle. I'm pinching it a little bit. Now I'm going to switch on, sir. So for some people in the back could not see it. Thank you. Thank you. That will be great. Good, sir. Hello? For some people who could not see from the back, I'm going to explain to you. Right. So the demo is open. Next is a question time, and I want wrong answers. Good, thank you. So now tell me, it is only for 2.4 grams, 2.5 grams. I put it there. Even when we were trying is hard to blow it out, it was not coming. Even with a blower, it was not coming. Can anyone tell me why? What is it? Areas increase. You have to keep thinking and living. There is no harm. All are in the same plane. Yes? Huh? அது அப்படி எக்ஸ்பேண்ட் ஆயிடுது. அதனால வெளியில வரல. Super ideas, but very good wrong answer. Okay. Good. So when you are getting such kind of a problem, there is one small trick you can play in many interviews and all that. You put some scientist name and say effect. You may be wrong. Newton effect, Einstein effect, Bernoulli effect, something you say. Oh, I have told the answer also. You know what is this? So, but Bernoulli effect is only for exam, man. You cannot use it for explaining things, can you? So this is the problem. She was also mentioning in the morning. The disconnect between what you study and what you see around. Where do you apply your knowledge? That is where the problem comes. So this is nothing but Bernoulli principle. I don't want to take too much time. So what the Bernoulli principle says, actually conservation of energy. That's what Bernoulli principle ultimately is. So he said, whenever a fluid is in motion at high speed, the pressure exerted by the fluid on the surrounding will be less. The fluid at rest will apply more pressure. This is all the concept. You will write it in equation, energy equation, half rho v square, etc. Mugged up and written exam, right? Okay. So now what is happening here? When the air comes out, when I put the ball, there is a small gap all around through which air will come at high speed. Why is coming high speed? A1 V1 is equal to A2 V2. What is that? Continuity equation. So here the area is more. On the sides the area is less. Therefore velocity should be more. Right? When the velocity is more, the pressure due to that ice flow velocity on the ball is less. Here, everywhere. But here which is stationary, and therefore it will be applying more pressure. So this fellow is not able to come out. Even when I invert, including the gravity, it is able to support. Unfortunately, I could not show it because the force was not enough. So that is the same thing happened even with the ball. When I take the big ball, when there is a jet which is coming, on perpendicular to the jet, the pressure is less. The surrounding air pressure is more. So it is always keeping it pressed to the jet even when I tilt it. If there is sufficient velocity, you can really go up to even 30 degrees. Very low, the ball will still be suspended in the air. So this is Bernoulli's effect. And what is the application of Bernoulli in real life? What is it? Aircraft. There are so many applications. Aircraft is a phenomenal application, which shows that a person sitting in some corner in Switzerland is a Swiss mathematician, Bernoulli, doing some simple calculation. Poor fellow, he got killed also during French Revolution. So when they were writing, you know what happened? That could be employed by using technology to make aeroplane fly. So how? Aeroplane is got aerofoil structure, curved at the top, flat at the bottom, and it will be always at a 4-degree angle of attack on the airport, right? And when the pilot runs it at very high speed on the ground, on the runway, air is going behind. Correct? It is going past the air at high speed. So the air going on the top, the V1, will be very high because it is very smooth. The air going at the bottom will be less because you have got the aircraft support against the flow. And therefore this velocity is less, this velocity is more. This velocity is more, this pressure will be less by Bernoulli. The pressure due to the air at the bottom will be more. So the aircraft will get a lift. That is what is called lift. And you will observe in the dial when it goes beyond mg, where mg could be the total mass of the aeroplane, pilot, steward and all the people, baggage, etc. He will take it up and then go. So a small, simple mathematical calculation theory proposed can bring about change in the life of hundreds and millions of people all over the world. Right? So that is a very important thing. Next is, of course, a magic box. These are all some magic experiments, so I want to do it first, then I will go back to simple principles in physics later on. So this is, many of you would identify LED. Everybody will say LED. Very good, wrong answer. This is neon lamp. This is a neon lamp. If you come closer, from a distance it will like LED is like that only. No harm. Is it wrong? Not at all. You are able to immediately connect and then tell it is LED. So there is no harm. So this is actually a small bulb with 2 electrodes. And you have a trace neon there. Gas. Sealed. So if I take these 2 leads and apply DC voltage, I did it in my lab. Till I came to 70, it was not glowing. Only at beyond 70 it started glowing. Why? Why it's glowing? 2 electrodes, I apply a voltage divided by distance between the electrode is called electric field, V by D. So the electric field becomes very high. It is so high when I apply 70 volts that it is able to ionize the neon inside. So the electrons are removed, ripped off, and therefore they start conducting. The ions go to the negative part of the electrode and the electrons go to the positive, and so that produces sound and light. So you are able to see the light. But then what happened? I got some magic box here. I have a magic box. So when I bring it close, I don't know whether you are able to see because of the ambient light. Can you see light? Can you see that lighting? Wireless lighting. There is no wire. I'm holding in my hand. Not only that, I can make it. He is holding one hand, one side. I am holding the other side, and I can make it glow. Right? And the bones. They can see. So you can see. And if we touch each other's hand, it will not glow. Short circuit. If I remove, can you see that? Okay. But I can show something even better. I have a small 1 foot tube light. So if I put it here, you will see it is glowing. We have to tell them. So because of the ambient light. So it is not very effective. So I will bring something which is more effective. But before that, I will show you what it is. Some of you would have seen it in some place. Can you see that? Now if I bring, you can see there is a light coming here. It is not very bright. If you close all the windows, you will be able to see. Now you will also see this neon. So even when I bring nearly 6 inches away, it started glowing. And when it comes closer, it is very, very bright. So you can see that it is glowing. But I will show you even better something. Other bits. Bring the picture. Some of you would have guessed what it is. Why is it happening like that? So I brought something which is very powerful so that everybody can see even from a distance. Now if I bring this, I don't know where. Now you see, this is magic. Right? It's glowing very brightly. Now tell me what it is. Any guess? Huh? Tesla coil. Correct. You open one, sir. Come. That, oh, super. Turn button. So you can see, this is corona. This is corona discharge. Turn around. You can see. Right. So, this is a real Tesla coil. You can see. This one, this is also a Tesla coil. But somebody used it for making it into a profitable business. So you put a bulb with some trace gases so that it can produce a beautiful plasma. So this is called plasma lamp. So if you go to a shop and buy in any gift shop, you have to say you want plasma lamp. It is available in other websites also nowadays. That it is nothing but a Tesla coil. You have, what is a Tesla coil? Who is Tesla? Nikola Tesla is a phenomenal guy. Okay, equivalent only to Thomas Alva Edison because they were fighting all the time. So that gentleman has great innovator. So when he died, you know what happened? The whole US military went into his house because there is so much of material that he has invented. So they all took it. It is not known to the world. He was doing wireless energy transfer. Now it has almost become a common thing. Then wireless energy. You saw wireless energy. When I take the neon lamp or the tube light, it is glowing. You have now modern kids, they know they can charge their mobile phone by using a wireless pad. All same principle. So what is it? This is a high voltage, high frequency generator. That is what Tesla made with a very simple set of coils and capacitors. That's all. And there are plenty of resources available in the YouTube. If you put DIY Tesla coil, DIY means what? Do it yourself. Tesla coil. There will be enormous resources available. How you can make with a Pepsi can. How you can make with a any other small pieces of material. So they will tell you, and it is interesting for children to try it out and do it. And so I have here mini Tesla coil. It is also available commercially. It's a solid state Tesla coil. The other Tesla coil is almost in the lines of what Tesla initially wrote. But this one, we know the principle. You have to have a high frequency oscillator. So use a transistor and things like that. Make an oscillator and we have just put it in a cover. So it is you require only 6 volts to operate this, and you switch on like that. So you can see same effect you can see. So what is happening here? This is a high voltage, high frequency source. High frequency means 10,000 hertz. High voltage means 10,000 volts. 10,000 volts, 10,000 hertz source. So it is radiating in all directions. And when I put tube light, at this end the intensity is very high. At this end the intensity is low by 1 by R square, 1 by L square, 1 by D square factor. Because as you go away, it is a spherical wavefront now. The energy is transferring there. And therefore you find the difference between the two edges is sufficient to strike a discharge. Therefore it is making the tube glow. That is what is happening. So this is a very interesting thing, and if you see in the literature, people from MIT, long time back, about 15 years back, they did WIITICITY, VTCT. VTCT means what? Wireless electricity. Physics, electrical, electronics people, all those people joined with a research group. They made a big coil here and they put a source here, electrical source. They put one more coil 2 meters away and then put a 60-watt bulb, and the bulb is glowing without any electrical connection. That means they are able to transfer electrical energy over a distance of 2 meters. Now there are several international conferences are held on wireless power transmission and all that. If they do successfully, they will never tell us. You know that. It is useful for so many other military and other applications. So they will exploit it. Next day, sir.
Good.
Nirmal.
I want you to see this.
Nirmal. So, switch on. So this is a very innovative design. After one Japanese professor, I went to an international conference in Malaysia, long time back, 1980. Okay, many of you are not born, I think. So this is a sine wave. I have now done it with LED, light emitting diode. Okay. Now, what I have done is I have got another sheet with only one slit, and I am going to push it inside. Now you see what happens. So now you can see what is going to happen. So there is a vibration. Can you see the vibration? Single vibration through the slit. Now what I do, I take it out and I use another which has got 3 slits. What are they? Now you see what is happening. Same picture. Sorry. Turn it first. You are able to see what is happening? Can you see what concept I am trying to help them understand? What is that? Phase difference. The vibrations at different locations in a sine wave have got different phases. Therefore, you see them moving with a slight phase difference, and therefore this can be very well shown. Right? Then I remove this. I use one which has got multiple slits. Now you see the whole sine wave comes. More numbers. I hope you are able to see that. It is a very elementary level, but many times these concepts are sometimes difficult to understand. That's right. And it is very interesting and useful.
I wanted him to show this because this is not commercially available anyway. And this is something which is done by us.
So,
Like him, anybody can come out with their own explanations. It will help their own search.
so this is standard thing nowadays available also. You can buy across the Google, what is that? Amazon or something you can buy. Everybody knows what it is. It's a different version of Newton's cradle. Okay? Our students do it with marble and all that. Marble and super glue. You can do it. How do you do this, sir? Sure. So every one of these, one has to assemble and then do the experiment. For want of time, I am keeping all assembled and showing it to you. But in a class, what I will do, I will give all them as a piece of material and they will have to. Okay. Now you know, in the Newton's cradle, you will have 4 or 5 pendulums, 4 or 5 pendulums, and you remove one of that pendulum, release, you know what happens? What happens? Only one is going on the other side. If I take 2 and release, how many are going? 2. When I release 3, 3 will go. When I release 4, 4 will go. But why? You are able to see? Anybody? What is the principle that you should apply in physics? Everybody knows. Conservation of momentum, how wonderful it is. Partially right. Conservation of momentum. Means what? They are all of same mass. M is the same. So it is coming and hitting with a velocity v, let us say, mv. On the other side, same mv. So one bob moves with the same velocity v, mv, right? Now I hit with 2 mv, right? Now only 2 goes with v. Why not v with m with 2v? You get my point? It is conservation of momentum still. 2m into v can also be m into 2v. But it's not happening. Only 2 goes with same v. Why? That means what? Conservation of momentum is not good enough. Yes. Somebody wants to say. Anybody? This is an elastic collision. In an elastic collision, both conservation of momentum and conservation of energy should be concerned. So that is all. Of nm v1 square equal to of n2m v2 square. I can assume all are different. Number of balls, velocity, everything is different. I can write a general equation. Before collision of n1 m v1 square is equal to of n2 m v2 square. Then conservation of energy means what I will do? of N1M V1 square is equal to of N2M V2 square. Now solve the equation N1 is equal to N2, V1 is equal to V2. So only when you have both the equations, it will obey this rule. Elastic collision, conservation, energy and momentum. Now this is standard, many of you would have done also. I am very conscious that there are very resourceful teachers here. They would have done many of these experiments in their class on their own differently. So I will be very happy to talk to you. This is a well-known experiment. There are number of ways of doing it. So I have a small trough. Because all the people should see that this is a good thing. So I have a small trough, plastic trough, in which we have taken water. In addition to the water, we add a detergent, soap solution, small 1 or 2 drops, or milk or something, which is a colloid. So when I apply, you know what is this? What is this? Laser. But can you see it in between? You are not able to see. Only you see at the end. You are not able to see the ray. Why? Monochromatic. Coherent. Why? Pardon? Same medium. So if I use the powder, chalk powder. So because there is no scattering centers for us to see. It is all going in one direction. How will you see? Only when the light gets scattered, how I am able to see all of you? All of you are able to see everything because the light is scattered by all the things. And therefore it enters into your eye and you are able to see. Therefore there should be scattering center. So if I use, for example, so you see here, you can see the ray. Can you see the ray? Now you are able to see. No. Narrower. So you are able to see even there, up to that. Can you see that? Why you are able to see that? Because there are scattering. That smoke is nothing but tiny particles, microparticles. They scatter light, so we are able to see. So therefore, I have added a few drops of soap solution or something, and if I show like this, you are able to see what is happening to the beam. Can you see?
Straight line.
You are able to see the beam. You are able to see the beam because there are scattering centers. I have added some material. Now I can do either this way. Can you see? Can you see? Row coming there and going there. Can you see what is the phenomenon I am trying to explain? Total internal reflection. Which surface? There is one surface at top, there is one surface at the bottom. Which surface is responsible for the total internal reflection? Can anyone tell me? Pardon? We know the condition. Light should go from denser medium to a rarer medium. Here also happening, this also happening. So you have to tell me where the total internal reflection happens. So if I keep on till at some stage it is going straight, and so it is this point which is actually the total internal reflection at this point. So it is here. So if I increase, see for example, now it is almost going straight, sorry. Now if I do like this, you are able to see at this point only total internal reflection. Increase the angle more than the critical angle. It comes not at the bottom. Bottom is almost a reflection, right? There is no medium here. So that we have to be careful. I will explain it. Right.
Bending rate comes from related.
Sure. You have a bottle, so very simple only. I have a hole here on this side. So if I release the hole, release the finger, you know what will happen? Now I line there is a now can you see the line here? Can you see? Why is it coming like that? This is fiber optics. This is it's not coming straight. Nothing is there. So light is going along the street. Light is going along the street. By how? What technique? Total internal reflection. So it is undergoing, when you do it above, see, you can see in my hand, light is coming. But when you come to that point, it is no more coming. The light is not coming, because if I put a hand here, you can try it, it will be green in color because it is coming. So this is the principle of the total internal reflection in the fiber optics, through which we are able to spend so many communication channels. That also many of you may not know how. How? Because you use light, you have got multiple channels. How? So radio stations are in the mega, our sound vibrations are up to 20,000, not even 20,000, but generally 10 to 20,000 is the range. Then radio frequencies are in megahertz, right? But light 10 power 14. So if you have in megahertz, if you want to shift, you will have less number of radio stations only in the neighboring area. But if you are at 10 power 14, you will have multiple millions of channels. You can have within a 1 gigahertz to 2 gigahertz. You can have several such channels, and therefore it increases the ability. Therefore, they say the telephone lines between North America and Europe can be transferred through one single fiber. So that is what I think. This is again a very simple experiment explaining a difficult concept. What is a difficult concept? Now I will show you, you would have guessed almost. So here again these are all to be assembled. Okay, everything can be dismantled. I have a platform, round platform. One side I have a small toy motor with a fan, and the other side I have a battery, 3 volts dry cell, and I have a small switch which can switch on and then turn the direction of the current, reverse the current. Both are possible. So if I switch on, what will happen? The fan will rotate, right? And if I switch off, the fan will stop. When I change the direction, the rotation direction will change. Now it is changing in the anti-clockwise, clockwise. Now what I do, I put it on a spike, suspend it. I suspend it such that it is capable of rotation about a vertical axis. Right? Now I stop it. Now I switch on. Nothing else I do. I gently switch on. See what happens. What is happening? The whole platform is rotating. Who asked this to do? Now I will stop it and then reverse. How is it now rotating? In the opposite direction. This is conservation of angular momentum. Right? So this is the total angular momentum before. Now, what is the total angular momentum for the platform? 0. Nothing is rotating. When I switch on, I am giving angular momentum to one part of the system, and it is isolated. Therefore, the platform starts reacting to that. To conserve, I have not put it in the right place. So when it is rotating in this direction, there is a vector, angular momentum vector in this direction. So the platform rotates in the opposite direction to make an angular momentum downward direction, to compensate, to make the angular momentum again 0. So that is what is happening. And now, why is it going slow compared to the fan? Fan is going very fast. This is going slow. Why? Because what is angular momentum? I1 omega 1 is equal to I2 omega 2. I1 omega 1 is for the motor. The fan is very, very small. I is small. Therefore, omega is very large. For the platform, I is large. Distribution of mass is very large. Therefore, omega is small. I normally used to show it with dumbbells on a rotating platform. In IIT, we have a big machine. We used to show several years those experiments. So, these are very simple. Anybody can do it. As a matter of fact, all of them are like that for explaining conservation of angular momentum. Yeah. This is also a simple but different expression. Distance and displacement. Many people have confusion with that. Distance, they will say one is a vector quantity, the other is not a vector quantity. They don't normally understand. So this is what I have here is I have a black thread. I have a black thread and also I have an elastic band, white color. The black color is a rope, just a thread. So I have got number of scaled parts I can take. So if I go like that, this bobbin will rotate and the string will keep increasing. I can put this across. Now if I ask anybody what is the distance, what is the displacement? I see that now the white line shows you the displacement from the starting point to the end point. The black shows the actual distance. So you can keep on playing with that. Somewhere here or here. You have to do it carefully. So now you can see the distance and displacement are different. The black and the white line. So that is what it's a very, very elementary simple thing, but many times simple things are more interesting to see.
Even this is not done by everybody. This is simplified by us. Show the vector.
Because I talked about angular momentum and all that, I have got anyone please come here. So I have two rods, right? You see some yellow thing here and here, okay? And the yellow is at the middle. You hold it in two hands at the middle. This also you hold. Now keep it away. Rotate both of them. Tell me which one is easy for you to rotate. Easy. Really? Which is easy?
Okay, this is easy.
You are compromising to come here. You come. I got confused. Because I said immediately, you change this. Now hold it in the center. Do it slowly and see which one is easy for you. Freely rotate, man. We are not able to make decision. Anybody can see. Come here. I don't know why you have so much confusion. Central hold it in the center. Come here. So anybody can see it is more difficult to rotate than this. Can anyone tell me why? I have given you some suggestion already by using that yellow label. Mass. So I have a mass here, a nut, bolt, or a metal piece put here and put here of same mass, but two pieces equal. Here I put them at the center, same mass. So I have got same mass. You can verify putting it on mass. This thing balance. What is the difference? The distribution of mass is different here and here. The mass is distributed far away from the axis of rotation. So the moment of inertia is more, therefore it takes more energy to rotate, torque. Here, much easier, more difficult. So it's a very simple exercise. Okay. In the same line, we are going to run a race between two objects. One is solid, the other is hollow. Correct? I can tell you can also verify later on, they both weigh the same. The mass is the same. Right? They have the same radius. They have the same height, everything same. Except this is solid, this is hollow. So now I want to run a race by releasing them from the top. Now what you have to tell me? A, B, C. A, both will come together. B, hollow will come first. C, solid will come first. D, none of the above. Good. Ready, sir? Ready, huh? You are ready? No. The color. This is solid. This is hollow. I am putting it on the left side. One more. No experiment you should do once and say European run on the road. You have to repeat many times. So I have solid here on this side, hollow on this side. So I am releasing it from the top. Which is coming first? Solid. Y. Same MGH. Transferring to kinetic energy. So it should come, both should come together. Why? Say something. Wrong answer only. All are same, no problem, don't worry. Good, very good reasoning, but excellent wrong answer. So, because there is a hole, here resistance will be there. That's what I put a small tape here, here and here. Still solid will come first. So it's much more intriguing than this. In terms of moment of inertia, do you know the difference? What is the moment of inertia of hollow cylinder? How many times you are attending the exam here? What is the moment of inertia of hollow cylinder? Solid cylinder. Anybody? mr square by 2. M is the mass, R is the radius. mr square by 2. This one, mr square. All mass is along the radius. Correct? All mass is along the radius. So mr square. So this moment of inertia is twice as much as this solid. But when I put it here, they both have the same potential energy, MGH. But what is happening when I remove? There is a translation. I put here, it comes here. So there is a displacement from here to here. So there is a change of place. Plus, they are not coming sliding, they are coming rolling. So because they are rolling, there should be a kinetic energy of rotation, rotational kinetic energy. Because they are moving fast, they should have kinetic energy of translation. So mgh should be equal to half mv square plus half I omega square. Half I omega square is rotational energy. Both should be there. So mgh. So now what is happening? This mgh is the same, left hand side. Right hand side, I is different. Half I omega square for the solid cylinder is half of half I omega square for the hollow cylinder because I is double. Correct? You understand? So out of the mgh back energy, this one takes more energy to rotate the hollow cylinder, and therefore has got less energy for translation. So it comes with much less velocity. A solid cylinder has got half I omega square, half of that other one, so it has got more energy to come down to the energy. That's what it happens. So again a simple example, there are spheres, cylinders, there are so many things that you can keep on doing. So this is also very interesting. Maybe we have to switch off the light, this portion only. This is a very simple, nice experiment. Some of them I copied from other resources. There are plenty of resources available. Okay. For those who are interested, there is a crazy guy by name. There are a number of crazy guys like me, but this guy is a phenomenal guy. His name is Bruce Ely. Bruceyeaney. Bruce Heaney. He's a school teacher in US. He has now retired. I was in contact with him also. He has done phenomenal kind of things like this. Plenty of wonderful things. Anybody can visit in YouTube. Put Bruce Heaney. Homemade Toys is the site. Homemade Toys by Bruce Heaney. So here what I have done is, I have connected a AC source and a DC source. Both I have. AC as well as DC. And this is for holding. And I have a switch here with which I can switch on or switch off. You switch on. Yeah? Okay.
DC.
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 Mother DC. So I am connecting it to DC. Now I switch on. Which is glowing? Green. Right? Now I switch off. I switch on the other way. Who is glowing now? Red. So what I have done, can you see? I have connected two LEDs back to back in the wrong directions. One is directed in this way, the other is directed in that way. In parallel to the 6 volts. So when the 6 volts is going from plus to minus, only one LED glows. From this side plus to minus, the other LED is glowing. I hope you can see that once more. This is green, this is red. Can you see that? So when I put green and rotate, I don't know whether you are able to see. I hope you can see. You will see almost a circle, continuous circle. I will try with that red. It may be easier to see. Can you see the red circle? Okay. Now what I am going to do, I am taking it and putting it into AC. What will happen? If I put it in AC and switch on, what will happen? Will both glow or only one will glow? Say something here. AC. Pardon? Alternatively. Well, excellent. Alternatively. That's a very good answer. Okay. Alternatively it will glow. Right? So let us see. Can you see both glowing? Right? How do you know it is alternately glowing? We cannot say 50 Hertz. Our persistence emission is 16 and above. So it is 50. 50 Hertz means we cannot see, distinguish. So I rotate. Now what will happen? You see a dotted circle. Can you see a dotted circle? And if you carefully observe, the dotted circle will be with green and red. Red and green both will be there. The green is not that bright. You should change the color. Right? Green also is there. I hope some of you can see that. Close quarters. So what is happening here? When I rotate, right, I'm tracing a circle. So therefore, I am able to persistence. I am able to bring it down the persistence of vision because I am doing it over longer distance, and therefore I am able to see the individual dashes of it. But because it is AC, for one half red is glowing, for the other half green is glowing. Right? Red and green. But if you carefully observe, what you see? In between there is a black. When both of them are not glowing, can you see that?
If actually this dark light level, you see the black also.
Yeah, the green is the color one. You have to use some other color. Okay. So you can see there is a black region. Can anyone tell me what is that black? It comes, if you observe carefully, you can try later and do it. If you do, red, little bit of black, green, little bit of black, red, etc. It goes. What is that? Little bit of no color. Pardon? That shows the diode requires a cutting voltage. She was showing in the morning diode characteristics. Diode will start conducting beyond the potential barrier. No 0.65 or 0.7 for silicon. Beyond that only so. So while going on the positive, 0.7 volts is lost. Beyond that only you are able to see the glow. Similarly at the bottom, another 0.7. So nearly 1.4 volts gap. The LED, both the LEDs are not glowing. Therefore you see the black. I hope you get the idea. It's a bit tricky, but it can be understood. So this is a very nice experiment to show half-wave rectification of both the halves, how AC it makes that direction to change, the current direction. Doppler. Okay, this is also very simple. Anybody can do it type of experiment. Here what I have. I have a 9 volts battery and I have a buzzer and I have a switch. Everything put in a small plastic box bottle. Battery, buzzer and all the wire I put inside and the switch is outside. So if I switch on, the buzzer will work, 9 volts. I have a small string tied to the bottle and now I am going to do something. See here. What is the sound you hear? Now you see what is the sound you hear. Can you see the difference? What is happening? It is waxing and waning. Wow, wow, wow sound. Can you once more. Observe carefully. Now there is nothing. Tell me what is happening. Tell me what is happening. What is the effect? Doppler effect. That's all. You don't have to do any big thing. Of course, you can draw in the graph on the board, waves coming here, they are all crowding here when the source is moving, all those things can show. Here is very simple. When I rotate above my head, when the source of sound is coming towards you, the frequency will increase. When it is going away from you, the frequency will decrease. Therefore, increase, decrease, so that, that's all, as simple as that. So, and then you can explain about Doppler effect, what is that, Big Bang, expansion, okay, all the planets and the objects, the stars, everything going away from each other. How do you know? Because from the Doppler shift of the radiation coming from those objects, you are able to see they are all moving away. If everybody is moving away, excuse me, if everybody is moving away, that means there is an expansion. So that is how they establish. Now there is a lot of controversy in that. There is also acceleration. Nobody is able to understand. So those things are. So a lot of physics is still waiting to be discovered by people like you.
Yeah, volunteer.
One volunteer, please come. So these are also very elementary. Many of them are very simple. There are so many things here which are also very simple concepts only. There is nothing very flashy here, but there are a few which are very good. For example, I would consider angular momentum conservation is a very excellent display which anybody can make use of in a classroom. So here, see, somebody was mentioning that I have opened a center after my retirement at this age. I opened a center in Haria, which is called a falling apple. What do you mean by falling apple? That is what triggered Newton. We have so many Newtons in our classroom. We are not able to trigger them because apple is already fallen. So I want to have a center where still apples are falling and our students should be able to recognize and ask questions and come out with idea. When is the time for our questioning? Everybody is running towards exams. They are worried about exams more than the knowledge. So how do you divert them? Parents want, teachers want, college wants, management wants, everybody wants marks. I want knowledge. Ultimately, when you move out of a college or school, what you carry with you is your knowledge, not your mark. Your mark will come as if they are coming to a no, only 1 or 2 years. Nobody will come and ask me or her, what is your plus 2 mark? Please tell me. It has got no meaning. So we are giving wrong importance to grades and marks. In the process, two things happen. Frustration for the student. 90, not good. You should have got 95, 98. You are not eligible to enter into engineering as if that is the ultimate aim of life. All these things all of us know. But how do you do that? So I decided I'll open a center. Children can come. What is the condition? No exam. No comparison between this guy, oh, he is doing so fast. This what? You can't come to anything. No negative comments. You have to only say wonderful, great, like that. And they should do it at their own pace. Somebody will be fast, somebody will be slow. It doesn't matter. Niels Bohr was very, very slow. Niels Bohr, you know, all Nobel laureate. There are jokes about Niels Bohr with George Gamow and all that. So some people, it doesn't matter. Speed is not the important criteria. Understanding and asking right questions is more important than even answering them. You ask the right question, you may find an answer later. He asked, why is the apple falling? Did he get an answer at that stage? Nobody could give him an answer. Then what happened? Normally what we tell our students, if you don't know the answer, skip, go to the next question. That's what we tell in the exams also. Don't keep dwelling on the same question. But this guy said, no, I cannot go anywhere, I have to find an answer to that. Why is the apple falling down, not going up? He spent years on that, reading many books, Tycho Brahe, Kepler, this, that, etc. Finally, he got the intuition idea that it should be to some universal attractive force that we mug up and write in all exam gets marks. So we seem to have missed something very critical, important in our education, which is to prompt students to ask questions, irrespective of whether it is a good question or a bad question. There is nothing like in IIT we have always a problem. Students will keep on asking questions because they are very bright here, cream of India, JEE, they come. So whenever they ask questions, what is the meaning? They want to test whether I know it. Right? It is not for them to understand. So bright. But if I don't know the answer, I immediately tell him, wonderful question. Sorry, I never came across this question. Give me one day. I will go back, read up and come back with an answer to you. He is very happy. He will never say, what is that? Doesn't know all this. He won't say like that. So he wants a person who will be able to approach the problem in the right spirit and come back. You should come back and explain to him next day. Why is it like that? That's the only thing. So therefore, there is no problem in finding the answer. You need not find all answers in this world. Not only that, we train them in such a way that for one question, there is one answer. Where is it in life? Do you find one answer to one question in life at every stage? The moment you finish your plus 2, nobody knows where you want to go to engineering, you want to go to medical, you want to go to this, you want to go to that. There are so many answers. You have to qualify the answers which will be most suitable for you under your given conditions. And therefore, we should not program them. We say, if you don't write what is given within the bracket in the textbook, it is not a right answer. So therefore, we should come out of it. There are many things which have come. Now it is all, you have to know only 4 ABCD only, right? These days. For competitive examination, ABCD. In IIT, I introduced online exam. Everybody said, no, well, how can computer not? Many people know it from rural India, etc. I said, don't worry, they have to know only ABCD. If they know ABCD, you know which button to press, right? And therefore, even in a PhD interview, if I ask a question to a guy who wants to do PhD in IIT and ask a question, sir, you want me to give the answer myself? Why don't you give me 4 choices ABCD? Then I will pick up. So he is programmed to that level. I hope you realize what I am trying to say. So therefore, the idea is that you should make the student think and make errors without belittling him. When he gives a completely wrong answer, you should not belittle, because I told you, in science anything can happen. tomorrow what he says will be the right one. And therefore, you should encourage and then analyze whether his answer could be right. So, these are what in my center, all of them, the children has to assemble and then do. Here, it's a very simple box, and I put a balloon, cut the balloon and put a membrane on top, and I put a mirror at the center. That is all. And then I have got a, you can use a red. Normally we use red, it's a bit rich, so he has used green. So if I use green, and then, on the wall you are able to see. Then what I do? So I speak into that. Hello. So if I speak into that, what happens?
The volunteer is there.
Try. You press this, show it there. Now shout into this. Shout. You can also shout anyway. So, sound is nothing but vibration. That's why we are only amplifying it.
Name.
Okay. So, you should have much lower frequency because the vibration will be at a lower frequency. So, you can see there are a number of ways of explaining how sound produces vibration. But it's a very interesting, fun way of showing sound is a vibration. Okay. So this is, of course, magnetic levitation and then about. Magnets, even today, is fascinating to me. I'm sure for everybody, right? And here, magnetic levitation is a very simple concept. Instead of going to the blackboard, writing through rectangular blocks and saying north, south, what will happen when I bring north to north? They should say repel. When I bring north to south, I will call the student, give 2 bar magnets, tell me how they behave. He will come and tell me, sir, when I bring north to north, it is repelling. So that is discovery time. They should learn on their own. So we do lot of experiments, simple experiments on levitation. I think some of them are there. Is already there? Okay. This is with all ferrite ring magnets. Okay. With all ring magnets, you can make it suspended in air, and you can also rotate, it will spin. Okay. The only problem is these ferrite magnets are brittle. When you drop, that's the end of the experiment. Okay. So this is again repulsion. But if I give these pieces to the children to assemble, they take lot of time because you have to properly align them and then make them in the right polarity. They should adjust. So after that, I show a small piece of wood where I have put number of ferrite magnets on the either side, and I have got a channel in which I have lot of magnets, and therefore when I put them on top of each other, so it is suspended. Then when I say, when you balance it perfectly, when you give a push, then what will happen? It will completely travel without any friction. This is the principle of maglev trains and all that in Japan and all that. You have a technology based on this. Okay, you can accelerate the small piece. If you make this as a carriage, so it can go smoothly. You have to spend energy only to propel it in the forward direction. You don't have to overcome any friction. The cars, battery, EV vehicles, okay, the energy spent in overcoming the friction is much more than useful translational energy. Therefore, this is a very important technical problem that we have to worry about. This is again a simple, interesting experiment. Some of you would have done it, I'm sure. Simple experiment. So I have a small coil, solenoid, copper wire. Okay, it is form of a bobbin, and I have a rod, metal rod, and I have a push button switch, so I can connect to a power supply, and then if I push it, current will flow into the solenoid. Now, then what I have? I have two aluminum washers. This is a complete washer. This is a cut washer. The washer is cut along the radial direction. Right? This is full. Now what I do? I keep it here, connect it. What else? I am putting the full washer first. Then I am going to press here once. See what happens. Can you see what happens? So this experiment is called jumping rings. The ring is jumping. Now what I do? I take it out and put the cut washer. I press. Not move. Why? Only wrong answer. What I am applying? AC or DC? AC. That's very important. You have to apply only AC. DC it won't work. Tell me, sir. Guess something. Eddy current. So it is electromagnetic induction. So it is a AC. So when AC is going through the coil, it will produce varying magnetic field. The magnetic field will go like a sinusoid, current higher, current lower, current, etc. And this is a conducting sheet. And so you can imagine like this. You know transformer. What is a transformer? You have a primary, you have a secondary. You pass current through the primary, what do you get in the secondary? An induced current. So this could be a one-turn secondary which is here. So when I pass current through the main solenoid, primary, what will happen in the washer? There will be an induced EMF. Right? The induced EMF actually we call, as she was telling, the eddy current. These are all eddies, small circular currents which will be produced. But because it is a continuous ring, the currents will reinforce and become a very high current throughout the thing, and therefore the effect of the induced current we all teach in the classroom in the Faraday's laws by Lenz's law, L-E-N-Z, Lenz's law. It is to oppose the change that is causing it. Therefore, the induced current will oppose the magnetic field due to the coil, but it is very less in mass. Therefore, he will be thrown off. That is how it is happening. Right? When I cut, what happens? The small eddies are not able to reinforce into large current, and therefore there is not enough repulsive force for it to jump. In addition, I will do one more thing normally, and that is I normally bring liquid nitrogen. Many of you would have seen, even here I have done it a few times. In the liquid nitrogen is a very low cryogenic liquid, minus 196 degrees Celsius liquid nitrogen boils, or 77 Kelvin. So I normally put this in liquid nitrogen. This one with a simple thread, I will cool it to minus 77 degree Kelvin, and then I will put, and then I will switch on. Before switching on, what I will do? Ask questions. I will say what will happen now. When I put here, I press, it comes up to this nearly. After I cooling it to liquid nitrogen and put it here, if I press, what will happen? A, it will come to the same height. B, it will be less. C, it will be much more. D, none of the above. Any guesses? Much? Why? Good. Correct answer. Why? Super. Clap. Well done. See, when you cool, what happens? Conductivity should increase. Why? We should keep on asking why. Why? What is resistance? Scattering of electrons in a lattice. When electrons are moving, molecules are vibrating at normal temperature. So when vibration in a big assembly, student assembly, if you ask one kid to run across, he will run. But when they are all doing exercise, can he run fast? He will hit somebody and fall down, right? So electrons are not able to smoothly go when the vibrations are there for the lattice. But when I cool to very low temperature, the lattice vibrations will become less violent. then the electrons will have less scattering centers and therefore more conductivity. They will be able to easily conduct. That means resistance drops. Because resistance drops, for the same induced voltage, the current becomes much higher. Therefore, it will be pushed almost this height when I put it in liquid nitrogen. So that's a very interesting extension. Okay, now another magic. I want another volunteer. Somebody from behind, please come. Come. Thank you. So here, you stand. I have two tubes. Some of you would have seen again, I don't know. But these are all so exciting for me. I do it because I enjoy doing it also. So this is a PVC tube, plastic we use for pipes and electrical wiring and all that. This is copper metal, right? And I have two items. I'll take one item. You have to catch at the bottom. I'm going to drop it from the top. Put it both to the hands. Both hands. Thank you. I drop it. See what happens. Is it coming out? Yes. Once more. No, you can see that now it is coming down. Now I am doing it in the copper rod. It's coming down. Once more. Coming down. Why? What silence? Why? Newton will do somersault in his grave. Why? Gravity. Don't say there is a hole in it. When some students will say there is a hole in it. Okay. Now what I do? I take another object and I am going to put this, and she is going to again hold it. It's coming up. We will show this side also. Come this side. Yeah. Now. I am dropping. It comes out. Right? Clearly, see? Now, thank you. You can go back. I want to do it with a copper tube, but I don't want a support because I'll put it and keep talking to you and then go and catch it at the bottom. Oh God, something is happening. Oh God, it's got stuck. Okay, sometimes it will happen. Some small burr will be there because of that. So I put it, I keep talking, and then I will go and catch it. Can you see that? Please come. Why? I have a micro switch with which I switch off gravity. I didn't tell you that. Okay, can you guess what it is? What this should be? Magnet. That's all. This is a neodymium boron iron alloy magnet. Very powerful magnet. This is a simple aluminium piece. So if an aluminium piece is going through copper tube, nothing will happen. But if I take a magnet, powerful magnet, put it through copper, what will happen? What will happen? Eddy currents will be generated, or you can say this is like a solenoid. This is a solenoid. Without insulation, if I wind coil, solenoid, no? Therefore, the magnet, when it goes through a copper coil, will produce voltage, electromagnetic induction. That's how Faraday showed first time. Okay, we all should be very happy. He is considered almost equivalent to Newton or even better for some people, because he was a bookbinder, as the story goes. From there he rose to that level. These days, without PhD, without papers, they will not let you in any lab. But in those days, it's possible. He was such an aggressive science enthusiast. So Cavendish pulled him, Davy, Sir Humphrey Davy, invited him to his lab to work as an assistant for him. And you know what he used to do? Every weekend he will show public lecture. There is no lecture there. It will be a big table in which all his apparatus will be there. He will show you what all experiments he did, how many of them succeeded, how many of them failed. And he will say, next time I will show you, I will make it happen. So that is how he will show. And he showed one day with a big coil and a magnet that there is a deflection in the galvanometer. And he was there was an MP sitting in the front bench. He said, Faraday, you think this is electricity, you are going to use it for any application? What is this? You are making such a big fuss. Then immediately Michael Faraday said, my dear gentlemen, in 5 years' time you will be taxing it. That's what we have. The electricity bill, everybody has to pay now. So every invention will be very, very modest, simple. Small kid in a kitchen, when his mother moved out of the kitchen, he was watching a kettle on the stove. When the steam started coming, the whole kettle started moving. Then he would say, hey, I can use it as an engine. Who is that? James Watt. Right? So, it need not be, I used to say, Newton did not go to MIT or Cornell or Stanford to get his degree, PhD or something, or did not write JEE to become a great scientist, right? So we seem to have missed the most important aspect of the knowledge component, the questioning ability, and trying to find answers. When a small kid, what is the first nursery rhyme, English rhyme they sing at home? Twinkle, twinkle, little star, how I wonder what you are. That is the enthusiasm with which the children learn. Then we keep on doing, scuttling their imagination, everything. Finally, 2 plus 2 is 7. He will write, my madam said 2 plus 2 is 7. So she will write. You have made them into programmable objects through our colleges and schools. Put them, stamp, BSc, MSc, PhD, like that. But the ability to ask questions, find answers is the most important part of the whole scientific culture and temper, right? So here what is happening? Because it's a solenoid and it's a magnet, it produces a current, induced current. And the current effect is Lenz's law. To oppose the change is produced by the movement of this magnet. So, and this movement of the magnet will be increasing in velocity. That means the rate of change of flux will be more and more as the time passes. At the rate of change of flux, more means induced EMF is more. That means more magnetic field, more opposing force. So the force that is opposing will keep increasing with velocity. The force which is allowing it to come down, mg, is constant, and therefore at some stage the upward force due to the induced current will balance the downward force due to mg. After that, what will happen to the magnet? It should come to rest, right? No, Newton. Every body continues in its state of rest or of uniform motion. So at this stage, when the two forces balance, this will have some finite velocity. With that velocity, beyond that there is no force because both forces are balanced. So it will come with the same velocity. Now we call it terminal velocity, and so it comes slowly, we can catch. This is what is happening. Stokes' law you would have done in the air, no? Due to viscosity, 6 by A eta V. And it is also proportional to V. Any force, opposing force which is proportional to V, you will get terminal velocity. When somebody jumps from the aeroplane, what happens? He will spread the wings. Once he spreads the wings, what happens? Upward thrust will be proportional to velocity 6 by A eta V, and the downward force mg is constant. Therefore, after some distance, the two will balance. No force on him, no acceleration. He will land on the ground without any acceleration, safely. Raindrops, same thing happens. If there is no atmosphere, raindrops will become equivalent to your aircraft velocity on a level flight. No human being, no plant can live on the earth. Because of atmosphere, there is a terminal velocity which is reached very high above, and so it comes very nicely, slowly, without any problem. So this Simple example of electromagnetic induction. Somebody made use of this for making some fun experiments. So I have a magnet, I have a coil, I have got two LEDs. One LED is connected in one direction, another LED is connected in the other direction. I put the magnet and I do like this. You will find both red and green will move up and down. You can try this way. Don't miss it, but this one. Okay. So you can share it with somebody if they are interested. Maybe I will stop it around some time, 3:45, and so that you can, some of you interested can come around, look at some of these, and if you want to try them, you are welcome to try them, no problem. And you can also give me your feedback about whatever you see. Okay, so let me explain. Now I have a small box with two chimneys, right? These are two tubes which I have fixed on the top of a plastic box, and I'm going to put a candle just below one of the chimney, and I will use a tube stick here. What will happen? Some of you might know. Let me see whether you are able to see. No, in front of me. Right. So I am going to put it so that it is aligned to one of the chimneys. No, height one. Height one. Now I am holding the smoke on the other chimney. See what happens. Now can you see what is happening to the smoke? It is going down. It is going down instead of going up. Right? So the smoke will come down. The smoke will come down and go like this. It will come like this, and I mean, from a distance you are not able to see. You can see the smoke coming out here. That is the right. Why? What is the principle? Some youngsters would say convection current, right? Because you put a flame here, the air above it will be warm. So warm air will be less in density, so it should start moving up. So when the air moves up, can you see the smoke coming? When the air goes up this way, the air should come to the other chimney. So there will be a circulation. Cold air will come from this side and hot air will go like this. So when I put a smoke there, the smoke gets into the stream of air movement, and therefore it comes through that and goes out. This is the principle of convection of gases. Right? Yes, then
345.
okay. So there are so many other simple experiments, Cartesian diver. So
We'll show this.
this is surface tension. It's always fun to work with bubbles and soap solutions and all that. So it is a simple ring and one small string I have tied, loose string, right? And I am now putting into the soap solution and gently I remove it. You see there is a filling. Now I prick one end, immediately you see what happens. When I prick, what happens? Both sides broken. Engage.
Vibration.
Now what is happening? It has become curved to the top. This is a filling. If I break this also, it will come back to the original. See once more. I break here. Now you see, it goes to the other side. Can you see that? Why? Surface tension. wants to stretch, keep the area minimum. Yeah, surface energy should be minimum. So therefore, it tries to shrink the area. The string is one edge, so it can shrink. When I prick on this side of the film, this film wants to reduce the area, so it pulls the rope and therefore the rope becomes curved. Right? For a given area, circle is the lowest surface energy. Similarly, I have a cube. So when I put and take it out, how will the bubble be formed? Films will be formed. Normal common sense will tell me one here, all the 6 phases will be having the film, right? Let us see whether it is true. I am putting it here. Can you see? It shows minimum configuration, surface energy. This is the best. There are so many very interesting shapes that you will get when you do this on your own.
Can you see?
You can come and do it later. Similarly, you have a pyramid. Again, you will think it should be on all faces, but it will not happen. It will again show you a minimum surface. Right? It will show you a minimum surface. Right? Now, yes.
Does it depend upon area or something?
Pardon?
Does it depend upon area?
It has to depend. It wants to keep the area minimum for a given configuration. So it's shrinking. Therefore, if all the 6 phases are having the film, that is having maximum energy. So it wants to reduce it. Then you can simulate it using MATLAB and all that. You can simulate it. You would find they come like this, they come like this. There is only one small region which is linking the two. That gives you the minimum area for that volume. So that is why it is. Okay, so I will stop here. Please.
Before the demonstration after this?
Please. Good. That way I wanted to myself see that. So she has brought a very beautiful box. Pandas, not Pandra box. It's a fantastic interfacing box. So many of you would have tried it with Arduino, with lot of sensors. Okay, it is very similar to that. Some of the features of the Arduino are also there. Of course, I have done a lot of experiments with Arduino before that other interfacing. But this is very interesting. They have done it in a very nice set of experiments also along with that. So I would like you to take over and show us.
In the morning there was a
You can take this maybe.
Otherwise it can become mic.
Mic, hand mic, give her.
In the morning there was a question regarding how to implement the RPTs in the school. Each of the problems which has been shown here actually can be converted into an RPPT. RPPT would be our topic. So topic would be angular momentum, conservation, it can be surface tension, any principle. And when it is added with a demonstration and you develop a questionnaire to establish a structure correlation, that if the size or the diameter is changing, what is going to happen? A questionnaire is also added along with the concept, and students are doing some activity along with that. So the half the work of RPPT is also done. And sir also showed that in our pipe when we are showing the movement of a magnet. In that case, one can try out how much time it is taking. And sir, it can be demonstrated with the help of XPICE. One see the whole visualization of that also. So that
you can actually find out what is the terminal velocity.
that's right. So each and every problem which is done here can also be done using interfacing as well as in the RPPT mode. So again, collaboration will help us in making those RPPTs and also pointing of problems which can be exposed to the students. So I have just got one demonstration for the XPICE kit, how to automate experiment with the help of that. So how to show is this screen visible? I don't think so to everyone. Okay. Can you just take it? Just take it. It can be both together.